Bernoulli trials. Repeated trials of an experiment are called Bernoulli trials if the following three conditions are satisfied. The experiment has two possible outcomes, S for success and F for failure. The trials are independent. It means that the likelihood of each possible outcome does not change from trial to trial. And the third one is the probability of success remains the same from trial to trial. Bernoulli trials are identical and independent repetitions of an experiment with two possible outcomes. For example, flipping a coin. The two possible outcomes are head or tail. The binomial distribution is the probability distribution for the number of successes in a sequence of Bernoulli trials. A person of age 20 years old has about an 80% chance of being alive at 65. Suppose three people of age 20 years are selected at random. We need to formulate the process of observing which people are alive at 65 as a sequence of three Bernoulli trials. Well, we have two possible outcomes. The person will be either dead or alive. The outcomes are independent. The likelihood of one does not change from trial to trial. And the probability of success, which is the fact that the person is alive, 0.8, stays the same throughout from trial to trial. The probability of failure, which will be 0.20, 1 minus 0.8, will stay the same from trial to trial. Obtain the possible outcome of the three Bernoulli trials. Well, we have three trials, two possibilities for the first, two for the second, and two for the third. Altogether, counting principle, 8 outcomes. And those 8 outcomes are success, 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 SSS, success, success, failure, success, failure, success, success, failure, 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 success, success, failure, success, failure, 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 success, and failure, failure, failure. The probability of each outcome. Remember that the probability of success is 0.8, 0.8 or 80%. The probability of failure is 1 minus 0.8, which is 0.20. So for the first case, success, 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 that probability will be 0.8 times 0.8 times 0.8. Using basic counting rules, and we will get 0.512. If we consider the second outcome, success, success, failure, that probability will be 0.8 for the first successful attempt, 0.2 the second, and 0.20 the third, which is a failure. and that decimal is 0.128. Now here's the table for every single one of them. Notice that if you add their probability, you should get 1. And here's the tree diagram that explains the process. Now we need to find the probability that exactly 2 out of the 3 people will be alive at 65. So exactly 2 will be SSF, will be SFS, and FSS. Only 2 people are alive, 2 out of 3. And from the table of probability, SSF is 0.128 plus SFS is 0.128 also, and FSS 0.128. Therefore, it's really 3 times 0.128, which is 0.384. Obtain the probability distribution of the number of the 3 who are alive at age 64. Well, number of people alive, you can have 0, 1, 2, or 3 people alive. For the 0, all of them have to be dead, so it's FFF, and the probability is 0.008. For 1, you need to have one S in the outcome. So it's SFF, FSF, and FFS. So it's 0.032 multiplied by 3. So it's 0.096. 2 people alive. So you need 2S. And we already have it here. So it's 0.384. 0.384. Now, 3 people alive, it's SSS, and that probability is 0.512. 0.8 times 0.8 times 0.8, 0.512. Remember that the total of all the probabilities is equal to 1.